All right, so starting off from yesterday, our last example we did was a square root function. So cube roots now. Cube roots, notice I don't have an endpoint this time. So because I don't have an endpoint, we have arrows at the end this time. Okay? So arrows at the end means I have no restrictions. It's all of the x values from left to right. So all real values, I'm going to highlight the whole x-axis this time. Okay, so that's the domain, all real values for the domain. So we're going from negative infinity to positive infinity. Okay. And so it's all real values, no restrictions. So the way we write this is in inequality notation, we have the less than and greater than symbols. So I'm saying from it's all of my x values are in between negative infinity and positive infinity. So we write that as negative infinity less than x less than positive infinity. So all of my x values are in between negative and positive infinity. It's all real values, okay? And interval notation is with the parentheses and brackets. The far left is negative infinity, but we can never reach infinity, so we put a parenthesis, comma. All the way to the far right is the positive infinity. We can't reach it, so we put a parenthesis. Okay? And then for the range are the y values. Whoops, that was a highlighter. For the range, it's all the y values. Again, there's arrows on both of them, so no restrictions. It's all real values for the range as well, okay? So I'm going to highlight the whole y-axis. And we're going from negative infinity all the way up to positive infinity, okay? All real values for the range. So basically, we're going to write it exactly the same as we did for the domain, except I'm changing the x to a y, okay? So from negative infinity less than y less than positive infinity. And likewise, I'm going from negative infinity to positive infinity, and then close it off with the parentheses. We never reach infinity, so we put parentheses to represent them. Okay? Now you can add yourself to a little note at the bottom. The domain and range will always be the same for cube roots. Okay, the cube root functions will always have the same domain and range. It's never going to change because there's no restriction, so it's all real values both for the domain and for the range. The only thing that's going to change I forgot to circle the cube root. This is a cube root function because there's no endpoints. I forgot to mention that in the beginning. It's a cube root because there's no endpoint. There's no restrictions. So the only things that are going to change are the end behavior and like the increasing, decreasing portion, okay? So end behavior, I have the two ends on the sides. So one of them is pointing to the right, the other one is pointing to the left. But it doesn't matter which one you start with. So let's just go from left to right. The left side is pointing where? Is it curving upwards or curving downwards? Downwards. Okay, and we're going to use this over here. It's a left down. So left is negative, down is negative. It's a negative, negative. Okay? So we say as x approaches, left is negative. G of x approaches down is also negative. Okay. Now the other side is pointing towards the right. And is it curving up or curving down? Upwards. So right up. Right is positive. Up is positive. So as x approaches the right is positive. G of x approaches up is also positive. Okay, and then the increasing, decreasing, we always go from left to right. Left to right, okay? So starting on the left side, going to the right, are we increasing or decreasing? Increasing. We're going upwards from left to right, okay? So the cube roots, again, will always have the same domain and range. The only thing that's going to change really is end behaviors and whether it's increasing or decreasing, okay? So if we look at our next example, looking at the next example here, is this a square root or a cube root function? Cube root because there's no endpoint. Good. Just like two arrows at the end. So this is a cube root function. It's like a S shape kind of. So the S shapes are cube root functions. All right, and just like I said, all of the cube roots are going to have the same domain, same range. It's all real values for the domain, so highlight the whole x-axis. For domain, it's going to be negative infinity, less than x, less than positive infinity. That's going to be the same every time for cube roots. So negative infinity, less than x, less than positive. Interval is negative infinity to positive infinity. The range is going to be the same, except I'm changing it to a y instead of an x. All real values. So negative infinity, less than y, less than positive, and parentheses, negative to positive infinity with parentheses on the ends. Those are always going to be the same. All right, then the end behaviors are going to switch here. So end behavior, looking at this one here, is that the left side or the right side? Left, going up or down? Up. So left up, what sign is the left? Negative, and up is positive. So it's a negative positive. As x approaches the left is negative infinity. G of x approaches up is positive infinity. Okay. Last one over here. This is a right down. Right down, what signs do you have for the infinities? Right is, question?
For the range, wouldn't negative infinity be greater than y, and y be greater than positive infinity?
Say that again? No. So, okay. So you're saying all of these y values are greater than negative infinity because you read it kind of the opposite. So it's negative infinity is less than all of these values. And all of these values are less than positive infinity. Oh, I was doing it, but yeah. Okay. So which infinity is the right side, positive or negative? The right side is positive, and it goes down is negative. So we say as x approaches the positive infinity, g of x approaches the negative infinity because it's going downwards. Okay? And then from left to right, starting at the left side to the right, is this increasing or decreasing? Decreasing. Good. Okay. How do you guys feel with cube roots? Do you feel like good? You need extra practice? You want to try the next one? You want to just move on? To another one? Okay. So go ahead and try this next one on your own. That's on your paper. Okay, so square root function because why? It has an endpoint. Good. All right, for domain, just to review what we did yesterday. The domain, you take your endpoint, move it to the x-axis. To find the x-axis, you're basically looking for the 0, okay? So the 0's here, that means this is the x-axis, this is the y-axis. So take the dot. Basically, you're moving it up just one time. You put the dot there. And then, is it curving to the right or curving to the left? To the left, so you shade the left part here, okay? Shade the left part of the x-axis. And then remember, we always go from the left side to the right side. So the left side goes all the way over to negative infinity. And the right side, what's that what's the x value there? Because of 3. The x value. Yes, the x value is 3. Okay? So for the domain, remember, it's the x values. Domain are all the x values. So everything that's highlighted, are all of those values smaller than 3 or bigger than 3? Smaller. So what symbol do we use? Less than. Less than or equal to 3. And then this is where people always get confused. They want to follow the arrow. Do not follow the arrow. You always go from left to right. It doesn't matter what way the arrow is pointing. Okay? So I'm going to put a note here. Do not follow the arrow. You always go from least to greatest. So go from left to right or bottom to top. Okay? So on the left side is negative infinity to 3. Okay? So negative infinity has a parenthesis because we never reach infinity. And we go to 3. And you can equal 3, so you put a bracket at the end there.
But if it goes to the right side, then 3 would be the one in the bracket.
Mm-hmm. Okay? But again, you do not follow the arrow. You always go from left to right. And if it's the range, you go from bottom to top. Okay? Alright, so now for the range are the y values. Now I have to move the dot to the y-axis. So y-axis is over here. You move it just to the left. And it's just basically 1 unit below. And then, is it curving to the top or curving to the bottom? The top. So you highlight the top of it. Okay? So what y value is that? My endpoint is at what? That's a -1. It's 1 below the x-axis, so it's -1. And it goes up forever to which infinity? Positive infinity. Good. All right, then the range, we're talking about the y values. So are the y values that are highlighted, are all of these highlighted bigger than -1 or smaller than -1? Bigger. So our symbol is greater than or equal to -1. And again, we're doing from the bottom to the top. So from -1 to infinity. So bracket -1 to infinity. We can never equal infinity, so you put a parenthesis at the end. Okay. Our end behavior, we're looking at this side over here. Is that the left or the right side? Left, going up or down? Up. So left is which infinity? Left is negative, and up is positive. So as x goes to negative, g of x goes to positive. As x goes to negative infinity, g of x goes to positive infinity. And again, you can say y if you don't want to say g of x is fine. My second one, though, that's the endpoint. Remember, we don't put anything for the endpoint. You kind of just ignore the second blank there. And again, do not follow the arrow. Do not follow the arrow. For increasing, decreasing, we always go from left to right. Do not follow the arrow. Start at the left side. Going to the right, what's happening? It's decreasing. From the left to the right is decreasing. Do not follow the arrow. Okay? All right, do you guys all understand why it's decreasing again? Why is it decreasing? Left to right is decreasing. Do not follow the arrow, okay? Do not follow the arrow. You're going from the left to the right is going down. Yes, PJ?
Wait, that's only on the ones that go to the left, right?
Basically, yeah. Okay. So if we look at our next example, this one's a practice problem. I want you guys to go ahead and try this one. Well, I want you to try this one because still people get confused still. So I want you to make sure you get it before you start doing your homework and then it's wrong. Double check your solution. Here's the solution. Again, do not follow the arrow. You always go left to right, bottom to top. Okay? That is our last example for today that we're doing together. Rest of the period, you guys are working on the assignment. It's already posted on Classroom, so you guys can turn it in when you're finished, okay?